fight for this tournament. And to start the fighting, so I would like each team, the team captain, introduce your team member. Let's start from the first reporting team, please.
Just stay here.
Yes.
Hello everyone. Here's Team Stanley, and we are from Zhubei Senior High School. My name is Curtis, and his name is Good, and his name is Ken, and he is Zhubei. Thank you.
Thank you. And the first opponent team, Kessa.
Okay, hello everyone. We are from Pindong High School, and we're
Team Testa.
Yeah, Team Testa. And this is Yuhan, 国军国好竞赛的人，我是右心。
Okay, thank you. And
Hello everyone, we are all-nighter from the Taipei American School, and then I'm Hyun Chan, here's Kenneth Mo, here's Charlene Lin, Justin Wang, and Alex Dong. Thank you.
Okay, thank you. Now I want to introduce the jury for this fight. My name is Chen Bao from Zhongzhen University. Then
I'm from the Zhongyuan Christian University.
My name is Jinghua Lu from NTNU.
My name is Jin Rong from Zhongzhen University.
thank you. So let's start the first round. I will ask the opponent to pick a problem to challenge the reporter. You have 1 minute. Okay, challenge the one topic.
Problem number 13.
Problem number 13. Okay, reporter, the challenge number 13, go ahead. Number 13. Number 13, right?
Yeah. Which one?
13.
What's the title?
Idol, experience.
I can't quite see it. Deny.
You don't have handle how the
Deny.
9. Okay, problem 29. So, opponent, you have a number.
Number 8.
Problem number 8. Problem 29. Okay, problem has been accepted. So each team, please write down the name your presenter on the bracket.
So hello everyone, I'm a reporter of Team Stanley. So this is my topic, future potential runs. And this is the problem statement. Place two electrodes into water supply for safe voltage and use a voltmeter to determine electric potential at various locations. Investigate how to measure potential lines deviate from your expectation for different conditions and liquid. So we think the main focuses is how the measured potential line deviates from your expectation for different condition and liquid. So this is a table of content of our report. And the first one we will start it by the introduction. And the second is the theory, and the third is the expectation of our experience. And the fourth is the derivation between the experiment, result, and expectation. And the last one is the conclusion. So what is equipotential lines? The equipotential lines is a line along which the electric potential is the same. The equipotential lines are always perpendicular to electric field lines. The potential line's value depends on the point charge and distance between the charges. Okay, so here's the theory. So the electric field versus distance integral equals the electric potential. So we can imply the equations of the potential had between two electrodes. And then we replace the Q with the known data. We can get the final function of the voltage, as you can see from the function. Radius, voltage are variable of function. And as you can see, the x-axis is a position and the y-axis is a position energy. The graph shows you guys that the strength of the exponential data, and which is exponential function. And this is an ideal situation. So according to the theory, we think the line will be distributed in the shape like a circle. And at the middle, the voltage or electric potential is equal to 0. And the numerical value is labeled unevenly because of the equation above. Okay, so this is our experiment equipment. So the equipment we use, as you can see, the yellow one is a digital multimeter, so which used to measure the voltage. And here is the water in a container, and the power supplier, and metal electrodes. And the paper which is used to report the result of the experiment. So here is our experiment data. And as you can see, the closer the line to the electrodes is a curved line. And the line in the middle is different. The line in the middle is different from others and appear to be straight. And the farther from the electrodes, the lower the voltage goes. Yeah. So this is our experiment data for the brine. And the result we found is completely different from what we expect. The line will stay in the middle and will keep approaching the negative electrode. We think that is caused by the uneven distribution of the solutes or about the electropolarity. So this is the compare and contrast. And you can see that the result is similar to our expectation. And we use water, and for example, the middle line is close to 0, and the potential lines around the electrodes are in curve shape. And this is our conclusion. So while we try out different solutes and concentrate on this experiment, we accidentally found that there's a potential lines will move around and cannot be predicted. And we found that the reason might be related to the electrophoresis and uneven concentration. Thanks for your listening.
Okay, hold on. You can take some quick questions.
The reporter returned page 9, so experiment set. So experiment set. Experiment. Okay. Can you make sure your material trade is the face of the material trade is clean? There are no any other substance.
So you say in the water?
No, in the face of this one.
This one?
Yes.
Yes.
Okay. Turn to the picture of your data. Okay. How can you make sure it here the potential in this light here? I think here the distance of here to here and this light is the same. According to the theory, we think here will be 0. What you think here is
So, can you say that again?
and we think this line will be 0 according to theory.
Will be 0?
Your potential. Your potential will be 0.
So there's still some voltage,
And your part is to slide to this line.
Okay, time's up. Okay, hold on. Your 3 minutes. Okay, prepare your
theoretical expect and the actual
Okay, opponent will stay.
Let's see the test again. In my office, initial and the reporter do this will and do this. Oh shoot. It's a story. Different. And here we think is an important part of this problem. Different condition and request. So, history report. We think your report theoretic model will literature and if understandable qualitative explanation of life according use of model and graph, but you luckily explanation theory and unclear prediction of different liquids and missing investigation of different areas. Incomplete investigation of the theory, bias, and experiment. Your experiment, you first data, some trends shows, test of, but you test of the no measurement of uneven distribution, and your function is not experimentally verified. Okay. Okay. And here's the point we want to dispute. Different charts, partition, and different island and liquid, and how to predict the phenomena, and how you do the experiment. Okay, thank you.
Okay, that's it.
Yes. How it works, you see.
Can you please repeat the question?
Huh?
Can you please repeat it?
Repeat. Do you think different charge precision will make this phenomenon different, or change your data or the shape of the potential line? If you think, then how it works?
Different position will change the voltage. I don't know what you mean about the phenomenon. Changing the phenomenon.
The phenomenon will change, but we think the shape of the potential line will be different. Okay, next problem, next discussion. You think different irons and liquid will change the shape of a positional line?
We don't use different iron, but we make sure that the different liquids will make the voltage change, because we use the brine and the voltage change in the same position.
But how it works?
I think it is because there is no loose bond or free electrons.
Okay, let's start with this one. How do you do your experiment? Can you show me in this again? We can make sure some detail your experiment.
Yeah, so we use the power supplier and we use the electric wire and we stuck it into the electrodes and we put the electrodes into the water and we use the digital multimeter to measure the voltage in different positions.
I want some picture of your potential line. Can you make sure each volt of between each potential line is the same, or you just drive? Yeah, so maybe you say
Yes,
okay.
we detect it.
So I want to turn to the page. You show your impression.
Any equation?
Yes.
Which equation you want?
This one. So in this line, R is the distance of the point to each different tracks, right?
So what is your question?
Okay. According to this, your distance to R2 is the R2 is the distance of R2. Oh, sorry. want to know, you can you explain your function of this? How you get this from equation about this?
Arrow type of R2 and R1 is radius of the electric.
Yes, we know if the distance from the point to each electric turn to next page.
Just a typo.
We want to know why this phenomena is uneven distribution. You said phenomena distribution. How would you explain it?
Image. Add this formula, and you can see the exponential distribution.
Okay. Here's the inner part for turn to the P2 of your next your expectation. Back. Okay, how would you predict it? The potential line is like this.
Because of the theory.
Okay. What theory? Your equation? This equation?
Yes.
Okay.
And also this one.
Is the potential of sorry. So report using what is A with if the A and figure the shape of this chart will change. According to theory, I think it is, but how it change or it change. So using A will affect this phenomenon, will affect this phenomenon, or it can lift the shape of this chart.
Can you say that?
Okay. We
axing different materials of the electrodes?
Louder.
What is your purpose of axing different material of the electrode? So you ax a different iron.
Yes, different material of the electrode, and we think it may change. It will may change the potential line. But when your equation, this will not in this lab equation in your equation.
I'm sorry, time's up. So anyway, 1 minute to summarize your discussion.
So reporter seeing different charge potential position will change the shape of the potential line, and although they don't do any experiment about different irons and liquids, they still think it will change the shape of the potential line. But they don't predict their particular phenomenon clearly, and they don't know what the meaning of the equation, and they show their experiment clearly.
Question from the viewer.
Hello everyone. So I was first want to ask question to opponent.
Okay.
So what do you think about the boundary condition that influence the overall inclusion line formation?
What?
For example, if you use metallic container or non-metallic container, how would that influence the overall shape of the inclusion lines?
What?
If you don't answer it, then it's fine. For reporter, what do you think about using the different material of the solution container will affect the overall shape?
I don't think it will affect the
Okay, I'll move on to the next point. My next question to the opponent is, what do you think about if you use the salt into the solution with the electrolysis, it will create the redox reaction around the electrodes. So what do you think about how the redox reaction products or the component will influence the overall shape of the inclusion lines?
Oh, I think you add more salt, in water, then the potential line will more collapse to the more solution.
Oh, okay, it's fine. For the reporter, I think you didn't consider about the local charge density throughout the volume container. So what do you think about the local charge density or maybe concentration of the cation and the anion throughout the container field?
we didn't measure.
Oh, okay. Then my next question is, since this one is saying that the line is exponentially increasing, but then the cation or anion size is finite around the electrodes, so there won't be the infinite exponential number of ions attached to the electrodes. So how do you think you can maybe modify this model with the finite size of the ions? Okay, so since the ion has a finite size, so it will not just exponentially increasing, rather it will reach the constant point. So what do you think about, what's your justification about just writing this as an exponentially increasing?
So we supply the stable volume.
Yeah, okay, thank you. For opponents, what do you think about the local charge density, since you mentioned about different charge positions?
This one.
Yeah, and also different size in liquid, as you mentioned.
Can you repeat?
So, how does the local charge density throughout the container will affect to the overall shape?
Oh.
I'm sorry.
Yeah.
Time's up. Okay. Viewer and 2 minutes before.
Thank you.
但是他如果是一个数据的，大家要查到。
Hello everyone, I'm Hyono from the team 09er. Today I'm going to talk about feedback for both reporter and opponents. So first, reporter did a really good job for visualizing the demonstration and how they measure and predict like potential lines. But then some cons is they do not consider the local charge density, boundary conditions, and also expectation does not really match the theory. And then there's no modification theory for the experimental results. For the opponent, he points out that the reporter has some lack of explanation that makes the result unclear. And then also talk about some multiple relevant parameters that they want to address into this phenomenon. And then the opponent really good job for asking how to justify theory for the determination, and also talk about how to ask what determine its exact potential lines based on the experimental and the theoretical. But cons is one cons is maybe they can do more time management by cutting out the reporter to get to his point more, and then maybe he can also talk about more details of the questions. Like for example, what is the intention for asking these questions? So there's some discussion points I want to talk about it. So first, opponent talks about experimental error because it could create the possible confounding variables, and then the reporter says it's negligible. But I think it's still possible to consider, since each material has different relative permittivity, that will influence the overall spatial equipotential light surrounding the electrode or the apparatus that the opponent brings up. And then the other point is that opponent talks about the consider different ions in the liquid, but then the reporter says they do not use the different ions. However, the ions matter because each ions will have the different redox reaction around the interface of the electrode, and then those products can also influence the overall equipotential lines around those product surfaces. And then they also talk about experimental setups and method for prediction, and also talks about some lack of consideration of the overall phenomenon. And then there are some few points that I want to talk about which were not really effectively addressed during the discussion. The first one is boundary conditions. So we should talk about the non-metallic boundary condition and metallic boundary condition. So Neumann boundary condition meaning there's no non-metallic boundary condition. While the dielectric meaning that there's metallic boundary condition. And if the boundary condition is metallic, the potential line will make the parallel line around the surfaces, so it will make the potential lines overall enclosed, while the Neumann boundary will make it more spread out, but only enclosed when it's closer to the electrode. Also, the other points I want to talk about is different salts and different concentration. Because different salt has a different cation and anion, and then it will have the different type and different rate of the redox reaction around the electrode that will create either depletion or accumulation that will overall contribute to the local charge density as I mentioned. And then we want to also talk about that in the stern layer, which is from the electrical double layer effect. The stern layer makes the cation or anion absorb from onto the surface interface, and it will create the proportional E field that makes the voltage stronger. It will make the voltage graph more drastically increasing around the electrode surface. So this is pretty much for my presentation for the reviewer. Thanks for listening.
About the solute evenness. Also, more data should be reported to show the lines and more connections between the theory and experiment. Thank you.
Okay, thank you. Now we go to a question from the jury. Anyone?
I have a question for three of you. If you change the solution, like if you put some salt into the water, what's the difference for your equipotential lines?
It will change, and the body will change at the same position, and we think. So we think it's because of the electromagnetic. Yes, and it's because the salt is no loose spin and the free electron. It's nice.
Okay, how about almond?
We think it will affect the potential line. For example, if you add more salt in the water, and then the shape of equipotential line, we think it will more close to expectation. You can get the real you can get your experience will more close to real value.
If you use the salt, then due to the electrolysis, the ions will move onto the electrode surfaces. And then based on the different salt, it will have different cation and anion, and it will interact with the surface interface of the electrode and then create a redox reaction. It will either create some gas emitting or could be create the deficit around it, and it will influence the overall spatial shape around the electrons. And then also pure water has a molar of the -10⁻⁷ molar. So there's still some H plus ion and then OH minus moving around due to the electrolysis. But then compared to the other salt, which has a higher concentration, the effect will be a little bit more negligible. So that the salt concentration equipotential line has a more drastic visualization of the stern layer or diffusion layer, or any other products or redox reaction.
Any other questions? Okay, let's go to the second section. let's start from the recorder. Going to space the score. 45545. So now for the opponent, please raise 54644. Now for reviewer, please. Okay. 78878.
Thank you.
Okay. So. Okay. Anyone want to make some comment about应该记得自己，大家记得自己的。Okay. So if no one want to make some comments, so let's close this file. So we take a 10 minutes.
10 minutes.
We take a 10 minutes break. So, but before you leave the position, please move your chair first. Okay. So the next reporters please move to the first one. Your opponents. Also check the projectors.